This presentation is all about graphing square root and cube root functions here. And notice you've got a y equals a square root function here. That's what they look like. This is a y equals cube root of x function here. Notice that only the cube root has the negative x and negative y here, because you can't have a negative y value coming out from under a square root. So keep that in mind as we plot these two functions here. We're going to look at some variations of these functions. For instance, here, what happens to the shape of the square root function if you have a coefficient placed out front, like this 2 here? Notice I've got three functions here. The base function in red, y equals square root of x. Another function where I put a coefficient that is less than 1, in other words, 1/2 out in front. And then another one where the coefficient is greater than 1. So here this situation is pertaining to this. Notice that it doubles all the y values. Notice that this is the red function, but it's doubled. When x is 1, for the base function you get 1, because square root of 1 is 1. Here it is doubled to where that number is 2, because this 2 out in front multiplies by everything that comes out in front of the radical. The next perfect square is at 4, where the square root of 4 would be 2 on our base function, yet that's doubled again. So no matter how you slice it, the blue line is double the values of the red line when you look at it. Now, same thing happens with the green one when a is 1/2, or when this is less than 1. When a is less than 1, the curve gets shorter and closer to the x-axis because all these values are cut in half. When the base value is 1 for this function here, well, that 1/2 makes this 1/2. Over at when x equals 4, when this is 2, it becomes 1 because 1/2 of 2 is 1 here. So notice what the a value does. It shifts the shape of the curve by either doubling it or by cutting it in half. Now, if a was -1, this would flip the whole graph over to where you get the graphs down below here. Okay, but we're not going to look at an example like that just yet. So understand what the coefficient does in front of the square root sign. It changes the shape of the curve. Now we're going to look at a different example. What happens if you add a value after the square root? Notice it's outside of the square root here. If I have a k value of 2, in other words, if I plus 2, it shifts the graph up. Notice the blue graph is 2 units above the red graph everywhere you go. From here, it's 2 units up. From here, it's 2 units up. From here, it's 2 units up. And at 1, this one is 3. So do the math. You can see they're almost parallel, except they're not straight lines. So that's what happens there. If k was a -3 outside the radical, then it's going to shift this thing down 3, as you can see here. When this one is 0, this one starts at -3. When this one is 1, it's -2. When this one is 2, it's -1. So everywhere it's -3. That's because whatever comes out from the radical, when you subtract 3, that's how it's going to change. It's going to shift the whole graph. So this can help you find the new vertex. If this is the vertex of my base function, then the vertex is going to shift up 2. If you've got a k of 2, it's going to shift down 3 if you've got a k of -3. That's how you find the vertex, and then the rest of the graph has a similar shape to our base function here, this red function. The other shift we're going to look at is h. What if I put something underneath the square root sign? If I put a 1 under there, notice if this is a -1, I'm looking for what I call x minus h. The minus is built into the formula, so if x is 1, h is a +1. It expects a minus there. Notice what the blue one does compared to our base function in red. Okay, the -1 shifted it over this way 1 whole unit. So the curve is the same shape, but it shifted the origin over at 1 unit. If I make h -2, in other words, there's a +2 underneath here. Remember that they're looking for a minus here, x minus h. So x plus 2 is an h of -2 to make that true. Okay, this situation, that's the green one. Notice it shifted it over to the left 2 units from my base function's origin. You moved it over 2 units. Here's my new vertex. And the shape of the curve is basically the same. It just shifted it over. So that's how these things change the shape of the graphs. Now, if we combined all three, if we had an a of 2, an h of 1, remember it's looking for the minus, so a -1 is an h of +1. So I have a equals 2 from here. I have h equals 1 from here. I have k equals 2 right here. That means the graph is going to shift over 1 and up 2. There's my vertex. Because h was 1, it went to the right one. It went up 1. Or I'm sorry, it went up 2. And then the shape of the graph, the a of 2, changes the shape. So the graph is going to look like this. So what I want to do with these square root functions is I want to find my a, find my h, find my k, Find the vertex according to h and k. Remember that h moves it to the right 1 unit every time h is plus 1. If h is 2, it goes 2 units to the right. If h is 3, it goes 3 units to the right. If k is 2, it goes up 2 units. If k is minus 3, it goes down 3 units. So find the vertex. Then what's going to happen is we're going to try to create a table of points, try to create perfect squares inside the radical, and that is how you are going to find your square root graphs. I'll show you some examples too if you look at the worked examples section, and that should help you.